Hi, welcome to another video from the Smart Enough factory. And this is going to be a bit of an origin story. This is about the factory in a box and essentially what it is you get in the factory in a box. Okay, we get a main board. Now, as I say, this is a bit of an origin story. This is the older board, the original prototype for the board version of the factory in a box. But I think it captures all the elements really well. We have an outline of the factory. In the factory we have what would be legacy machines, and these are just simulated machines. We have our Smart Enough factory nodes, which we add to our legacy machines. And we do that because we're interested in Industry 4.0. We're interested in capturing data, production data from these machines, because we're interested in looking at the overall equipment effectiveness. And one of those characteristics of measuring overall equipment effectiveness is utilization. So by adding these two lightweight, low-cost sensors to an existing machine, by picking up outputs from the machine, and power in this case as well, and those outputs are simply PLC outputs or relay outputs, we can capture enough information to work out our utilization. So what's the rest of the board represent? So we've already covered we have simulated machines. Okay, the wires that are here are actually, that's their product. This happens to be an input buffer to this machine, and this is its output buffer, which goes to the input of this machine, and the output of that machine feeds this machine. So essentially this is a miniature production line and it's cyclic or circular. The idea of having these boards here is that we can connect them to real processes when we're ready, and we can use this board to explore the utilization or the creation of say visual systems. So it's not complete. I've only just really talked about the machines. So these devices, these are wireless devices. They're utilizing the Digi XB modules, and these are through-hole modules. So there's one on each machine. They're taking 2 bits of information, and they form a wireless network with this edge computer. And you can see it has an endpoint or a similar device attached to this Raspberry Pi. And the Raspberry Pi is a LRWPAN, which stands for Low Rate Wireless Personal Area Network. And incidentally, these devices have been specifically designed to work in an industrial IoT type of environment. The modules use for their radios, they're on the 2.4 gigahertz frequency, and they use the standard, the 802 15.4 standard, or Zigbee. And the 3 versions, the 3 series of XBs work with Bluetooth as well, but these ones are running on 802 15.4. So every time an event occurs on these machines, these 2 digital inputs to the XBs are masked so that we can see just those 2 change. And if any of those 2 change, then a message is transmitted from this one to here, or from this one to here, and then that's it. Every time an event occurs, that happens. This Raspberry Pi is our edge computer. This one is connected to our factory router, or to the wide area, the LAN or the WAN or whatever, but it's represented by a connection through Wi-Fi in this particular case, but it does have an Ethernet port, to the cloud. So this computer takes those messages via its serial UART here and creates essentially an MQTT topic around that's distinguishable by a machine, and that topic, the message payload of that topic, contains the events or the state of the machine. This Pi also includes a timestamp on that MQTT message payload, and that's it. So This is acting as an MQTT publisher. In this particular case, we have the broker actually on the Raspberry Pi as well, but it doesn't need to be. It could be on the network elsewhere. And that's the factory in a box. So there is absolutely no connection between the simulated machines by these USB cables and this Raspberry Pi. Currently the only thing that's missing on this for it to work is the power input. The reason I'm showing this is that this was then replaced by this, which is a more compact version. In fact, this one's running, so we'll just turn them on and we'll see what happens. So this more compact version is essentially exactly the same. The outline, the board represents the factory. In this particular case, the power is derived from these USB connections. So that means we can just have a self-contained board without needing to have an extra power supply. The connection to the cloud again is through the Ethernet port or through wireless. And this device, this is a USB dongle version of these, is the wireless connection between these 2 points here and this USB dongle. This edge computer again is running everything. It's running Node-RED, which we're going to use, or we use for our dashboard and our back end. It's a low code open source environment, which is really suitable for IoT and in that case Industry 4.0 type activities. We run a database, PG, a Postgres database. We run a PG admin on here as a server. We run the MQTT broker, Mosquitto, on here as well. It's a DHCP server and it has a real-time clock. There's some basic parameters. These are the standard parameters for channel and PAN ID, which is there because these devices need to be on the same channel, the same PAN ID, and in order to communicate, and they're set up to send a message every time an input changes on here. These machines, instead of having them looped together, they're looped around each other, so the output becomes the input, and we can see these are actually in production. We can stop them if we don't hit it too quickly, hold it down too long. We can stop and start. We can change the configuration as well, and they are set up as machines. They break down, they run out of work, they have warnings and alarms depending on what's gone on with them. But essentially that's it. This is self-contained. When it comes to connection to your factory, we can move that to one side and we can bring in the real deal. Apologies for the cables. I'll just try and reconfigure that. Okay, back again. I had to do a little cut there. We run out of power. However, I took the opportunity to sort of show you, rather than just say what I was talking about here. There is no connection electrically or sort of cable wise, and there's no physical cable connection between these two simulated machines and the edge computer. I've just taken the opportunity to add an extra USB power supply to power these two simulated machines, in the same way that this real again a simulation, but closer to the real deal for a machine with a legacy PLC and a 24-volt power supply for the outputs, is essentially separate from this side here. So the connection that is made is via the wireless devices. So these wireless devices, this one that's labeled Fab4, this USB stick here, and this board and this board. By the way, these two boards are slightly different from this one. These are set up for Dry contacts, as in auxiliary contacts. This one's set up for direct connection to an output, a 24 volt output in this case. The boards are marked accordingly. And I've taken the opportunity to plug in a network cable to show that this is your edge computer and it's connected to your network, your factory network, either wirelessly or in this case by an Ethernet cable. And we're showing that connection to the cloud in this particular instance. So again, to recap, this is these two devices and this third device, they form essentially a peer-to-peer, or well, it's a star network with this one here. It's peer-to-peer in a sense that there is no coordinator, and that's a term for these devices in this 802.15.4 space. They're all set up as endpoints. However, the star concept comes in where each of these nodes is configured to send, when their inputs change, to send a message to this device. And when this device reads those messages, it then, via its UART, transmits a particular frame style, which is a 16-bit receive frame, to whatever's on the other end of its UART, which in this particular case, by an STDI chip, is converted to a USB import to this device. This can be plugged into any computer with a USB port. And that's the overview. So this is only one half of the factory in a box. On the right we have the simulation. On the left we have closer to the real deal, with an example of how you would configure them. So we have, for reading from sort of left to right, we have 24 volt power, we have 24 volt ground, which shares that with a signal ground, and we have the two digital inputs, DIO 0 and DIO 1. We're only looking at two because it's pretty straightforward to just use a very minimal amount of inputs to this device, which are clearly outputs from the PLC, to look at machine state. And the reason for two is that we were able to see whether a process, which is simulated by this one, is either running or stopped. And with the other one, we're seeing that the machine is idle, or sort of essentially ready to work, but it's not doing any work. So we can find out that it's actually sort of off, in an off state. We can find out if it's in an idle state, and then when we start our cycles, and this is a simple 5 second and 1 second sort of cycle that simulates the machine operation, that the machine is busy when the red light's on, or idle when it's off. Clearly this can be a longer running process, or a shorter running process. It doesn't need to be as regular as this, but this is just a set up as an example to see the data. And we will look at the data in our next video. Thank you for watching.